The most basic way to use aggregate functions in a SQL query is to use them in the select list. Here's an example to demonstrate this. Recall that the aggregate function for counting is count, and the syntax for using this function to count rows is count star. If you want to use the count function to count the number of rows in the employees table, then here's how you would do it. Select count star from employees. This returns a result set with just one row and one column, containing the number 5. There are 5 rows in the employees table, and the count function aggregated over all of them, reducing these 5 rows down to a single value, the number 5. You can use a column alias to give a name to the column that's returned by this statement. After count star, add as num_rows. So now the result column is named num rows. The example I just showed used the aggregate function count. Here's an example that uses sum. Select sum salary from employees. This returns the sum of all the values in the salary column. They add up to 185,403. And again, you could add an as expression after sum salary to give an alias to the result column. So count and sum are aggregate functions, and when you use an aggregate function in a select clause, like in these examples, it makes an aggregate expression. So count star and sum salary, those are aggregate expressions. You can include 2 or more aggregate expressions in the select list, like in this example. Select min salary as lowest salary, comma, max salary as highest salary from employees. This returns a result set with just one row, but with 2 columns, one for each of the aggregate expressions. You can see the lowest salary in the employees table is 25,784, and the highest salary is 54,523. Those examples all used very simple aggregate expressions. They all had just a single aggregate function with no other functions or operators. But you can use more complex aggregate expressions. For example, this query returns the range or spread of the salaries in the employees table. The aggregate expression is max salary minus min salary. Here's another example of a more complex aggregate expression. This one answers the question, if there's a 6.2% payroll tax for each employee, then what's the total tax for all employees rounded to the nearest dollar? The aggregate expression to compute this is round sum salary times 0.062. You can also use an expression as an argument to an aggregate function. The argument does not need to just be a column reference. It could be any valid expression. In this example, the expression round salary times 0.062 is used as the argument to the sum function. This is just another way to answer the question from the previous example, although the round function is applied differently here, and this might make the results slightly different. In each of the examples I just showed, the expression aggregates over all the rows and returns a single row. That's what makes these expressions aggregate expressions. They can combine values from multiple rows, aggregating them together. These are different from the kind of expressions you learned about earlier in the course, which operate independently on the values in each row. Those are called non-aggregate expressions, or scalar expressions. They return one value per row. When you write SQL queries, you need to be careful about mixing aggregate and scalar operations. You can use aggregate and scalar operations together in an expression, like in some of the statements I showed. For example, you can take an average, then round it. Average is an aggregate operation, and rounding is a scalar operation, but they can be combined together like this to form a valid aggregate expression. You can also use scalar arithmetic operators together with aggregate functions to form a valid aggregate expression like in this example, where you take a numeric column, multiply it by a literal number, then find the sum. But aggregate and scalar operations can form invalid expressions in some cases. For example, you might try to use an expression like salary minus average salary to try to compute the difference between each individual employee's salary and the average salary of all the employees. The right side of this expression aggregates, but the left side does not. And as a result, this expression is invalid and will throw an error with most SQL engines. There is actually a valid way to compute the difference between each individual employee's salary and the average salary of all the employees, but this is not it. And that's a more advanced topic that's beyond the scope of this course. Also, you cannot use scalar and aggregate expressions together in a select list. For example, this query has two items in the select list. The first is just the column reference first name. That evaluates as a scalar expression. It returns a value for each row in the employees table. The second is the aggregate expression sum salary. That returns just one row that aggregates all the salary values in the employees table. You cannot use both of these types of expressions together in one select list. Most SQL engines will throw an error if you try. When you use aggregate expressions in the select list, you can also use a where clause. You learned about the where clause in the previous week of the course, and you can continue to use it in this week of the course and beyond. For example, to answer the question, how many employees make more than $30,000, you could use count star in the select list, together with the where clause, where salary greater than 30,000. This returns 3. However, do not try to use aggregate expressions in the where clause. The where clause always processes individual rows, so you cannot use it to examine aggregates. All the aggregation examples I showed in this lesson returned a result set with only one row. They all aggregated the whole table down to a single row. But what if you wanted to aggregate subsets of the table and return a result that gives separate aggregates for the different subsets? This is what the group by clause is for. You'll see how to use that clause in the next lesson.